Hello students, how are you all? Welcome back to Akshar ID Foundation classes. I am your chemistry faculty S. Mohan. So students, in the previous class, we completed one very important chapter, that is General Organic Chemistry. So in the General Organic Chemistry, we studied just about the basics of organic chemistry. What is organic chemistry and what are hydrocarbons, how many types of hydrocarbons, saturated, unsaturated, alkanes, alkenes, alkynes, and functional groups, and nomenclature is very important. That nomenclature, this all we discussed in the general organic chemistry, right? Now one of the most important topic from the organic chemistry only is isomerism. So students, isomerism is not different topic, it's a part of organic chemistry only. Okay, so in the organic chemistry chapter what you have studied, so that this is the extension for that topic. Okay, and of course it's easy topic, but little concentration is required. Okay, and the topic, the chapter is isomerism. What it is? Isomerism. So simple topic, easy topic. In coming classes maybe it may be little difficult, but as of now it's very easy to you. Right. So isomerism means compounds having same molecular formula but different physical and chemical properties are called isomers, and phenomena is called isomerism. Clear? Not so clear, right? Sure. For example, student, if I have one formula like seawood, right? Seawood. So when I ask what is the name of this one, immediately you say that it is a carbon dioxide, right? You say that it is a carbon dioxide. If I write formula H2O, then you say that it is a water, right? But this isomerism means what? Formula remains same. Okay, like for example, formula remains same, but that possess different properties, different physical and chemical properties. Now question rises that formula same means what? The number of, how it is composed, means what are the atoms or elements are present in that. If the same elements are there, how come it shows the different properties? Okay, so in simple I'll explain you. For example, do you know what is the formula of glucose? The biology might have studied about the glucose about so much, right? So what is the formula of glucose? Yes, very good. That is what? C6H12O6. Okay. Now fructose, another compound called fructose. Okay, another compound is what? Fructose. Do you know what is the fructose? The biology, it has come anywhere? Fructose? So fructose formula is also C6H12O6. Now question rises that whether this glucose and fructose, okay, I written the same formula, that C6H12O6, C6H12O6. Now glucose and fructose are the same compounds? No. Glucose properties are different and fructose properties are different. Glucose consists of, already we studied about the functional groups, right? So glucose consists of aldehyde functional group. What it consists of? Aldehyde functional group. Fructose consists of ketone functional group. Ketone. So glucose and fructose are two different compounds having different physical and chemical properties. But you see here the formula remains same. Means glucose and fructose both are made up of 6 carbon atoms, 12 hydrogen atoms and 6 oxygen atoms. Same. But these are two, glucose and fructose are not same compounds, they are different. They are different in physical and chemical properties. Okay. So such compounds, this type of compounds are called isomers. What they are called? Isomers. And this property, the phenomena is called isomerism. Isomerism. This is our chapter name, isomerism. Clear? Okay. So chalo right now. So isomerism. What is the definition of isomerism? Isomerism means what? Compounds. Okay. Compounds, two or more compounds having same molecular formula but different physical and chemical properties are called isomers and phenomena. Is known as isomerism. This is a definition. Chalo, once read everyone, you read isomerism definition. Compounds having same molecular formula but different physical and chemical properties are called isomers, and the phenomena is called isomerism. Come on, study, read for 1 minute. Finished? Chalo. We go to the now classification. So if you see the classification, isomerism is mainly classified into two types. How many types? Two types. One are called structural isomerism and second one is called stereo. Okay, stereo isomerism. Under the structural isomerism, there are again so many types out there. Like in that first one is chain isomerism. First one is what? Chain isomerism. And the second one is position isomerism. And third one is functional isomerism. And fourth one is metamerism. And fifth one, tautomerism. Okay, and then here stereo isomerism, again two types are there. Okay, one is called geometric and the second one called optical. Okay, geometric and optical isomerism. So isomerism is of two types. One is called structural, second one is called stereo. In the structural, chain, position, functional, meta, tautomerism. Okay, and stereo, geometric and optical isomerism. Right. So today we discuss about the structural isomerism. Okay, 1, 2, 3. Let's try to complete at least 3 today. Okay. So the first one is what? Position chain isomerism. Okay, the first one is chain isomerism. So students, here chain isomerism means what? Compounds having same molecular formula. Okay, molecular formula remains same, but they differ in the root word or longest chain. Root word means already we discussed. Eth, meth, prop, but, pent, hexyl, like long chain. Okay, while giving the nomenclature we discussed, first you need to select the longest chain. Right? So that chain isomerism is what? If there is a difference in the chain, then that is called chain isomerism. Okay, let's see now how you can understand. For example, let us take, I will take butane. First, let's go with the butane. Chalo. Now you say, what's the formula of butane? But, root word is but. How many carbons? Meth, eth, prop, but. So 4 carbons. Next is what? Ane. Ane means what? Alkane. Alkane general formula is what? CnH2n plus 2. So N is 4 here. 2n plus 2. 2 4s are plus 2. 10. So H10. This is a butane. Okay. So this is butane. You know that this C4H10 is butane. Okay. Now see now. Now I'll write the structures of this butane. So first one, what I do? 1, 2, 3, 4. See, 4 carbons are there. And this is ane. Ane means what? The single bonds. So put the single bonds. Alright. Now carbon valence is 4. It can form 4 bonds. And 1 bond is formed with this carbon. So more how many it requires? 3. So 1, 2, 3. Okay. I'll write like this. 1, 2, 3. And this carbon has 2 bonds. One there, one here. 1, 2 requires. It also has 2 bonds. So 2 require. Okay. This has again 1, 1, 2, 3. So now this how can I write? Okay. Now I'll put the hydrogens here. Okay. So now see here, this carbon is attached with how many hydrogens? 3 hydrogens. So write CH3. Now this carbon is attached to 2 hydrogens. So CH2. Now this carbon attached to how many carbons? 2 hydrogens. So write 2 hydrogens. Yeah, this carbon is attached to how many carbons? Sorry, how many hydrogens? 3 hydrogens. Okay. So this is a simple structure. Okay. Now the same structure. Okay, the same formula. I'll write some in different way. So here you see now. Now see, I'll take 1 carbon, 2 carbons, 3 carbons. I'll take only 3 carbons here. Okay. Now I want 4th carbon. So I'll put some 4th carbon here. Okay. So I'll put here. Okay, 4 carbons. Now in single bonds. So 1, 2, 3. Already 1, 2, 3 has come. So only 1. This only 1 has come. 1, 2, 3. It has only 1. So 1, 2, 3. Right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right. So this is the structure. So 1, 2, 3, 4 carbons, 10 hydrogens. This how can I write? See now. So this carbon is attached with 3 carbons. So I write CH3. Okay. So here I write exactly below of this one. So this carbon is attached with 3 carbons. So I write CH3. Okay. Single bond. And this carbon is attached to only 1 carbon. So I write CH. Right. But this carbon is attached to another carbon which has 3 hydrogens. Okay. So I'll write CH3. Alright. Now this is a carbon. This second carbon is attached to this carbon which has attached with again 3. Alright. Chalo. Now you say this also 1, 2, 3, 4 carbons, 1, 2, 3, 4 carbons. And here 3 plus 2, 5 plus 2, 7 plus 3, 10 hydrogens. Here also 3 plus 3 plus 6 plus 3, 9 plus 1, 10. See, for instance, both are having the same formula, right? Then where there is a difference? Here the longest word, root word, here there is a straight chain. In the straight chain, how many carbons are there? 4 carbons are there, right? 4 carbons are there. So what you can give the name to this one? Butane. Butane. And generally we write N-butane. What do we write? N-butane. Okay, that is natural butane. Now for this, if you want to give the name, already nomenclature we discussed. What is the name of this one? First you have to select the longest chain. So 1, 2, 3, 1, 2, 3. And here we take 3 carbons only. 3 means what? Probe. So write probe. And single bonds are there? Ane, propane. If you give numbering from anywhere, 1, 2, 3. So this is propane is done. But for the second carbon, CH3 is there. CH3 is what? Methyl. So what I need the name? 2-methyl. What is the name of this one? 2-methyl propane. The name of this one is 2-methyl propane. And the name of this one is butane. Okay. So both are having same formula. But does they possess a similar properties? No. They do not possess all similar type of properties. Why? Because here it is a straight chain with the 4 carbons in the chain. But here you see only in this chain 3 carbons only are there. So there is a difference in the structure. There is a difference in the structure. This is linear. Linear means what? Straight. But this is what? Branched. Branched means what? Okay, this is a branch attached with some other carbon compound, right? So here these two are differ in where? In structure. Where they differ? Structure. So that's what chain isomerism is a part of structural. Okay, structural isomerism. Did you understand? Okay, so that. Now let's take 2 more examples. For example, if you take pentane, okay, pentane, come on, see now, what is the formula of pentane? You give the name, formula of pentane. So how can you give the formula? One is pent, second one is ane, correct? So pentane. Pent means how many carbons? Meth, eth, prop, but, pent. Pent is 5 carbons, right? 5 carbons. Ane means what? Alkane. Alkane is what? CnH2n plus 2. So 5 2s are 10 plus 2, 12. So this is the pentane formula. And now this pentane also possesses any isomers? Yes. So pentane also it possesses isomers. So see now, here I'll write the 3 different structures. See now, 1, 2, 3, 4. Single bond, single bond, single bond, because ane. Okay. Now this carbon is attached with 1 carbon, so it requires 3 more bonds. So CH3. This carbon attached with 2 bonds, 2 carbons, so it requires 2, CH2. I repeat now, 1, 2, 3, 4, 5. 5. Okay. And here also attached 2. Here also 2 required, but here only 1 is there. So 3. Okay. So 1, 2, 3, 4, 5. 5 carbons. 3 plus 2, 5 plus 2, 7 plus 2, 9 plus 3, 12. So 12 hydrogens, right? So this is one way. Okay. In other way, how can I write the structure? So I'll write here now second structure. Okay. Second structure, I'll write like this: 1, 2, 3, 4. And one I'll write here. Okay. This carbon is attached with only 1 carbon, so it requires 3 bonds. So I'll write CH3. This carbon 1, 2, 3. Already 3 bonds are there. It can form only 1 bond. So I'll write CH. Yeah, this carbon has 2 bonds, so it can require 2 bonds. So only 1 bond, so 3 hydrogens. Here it has only 1 bond, 3 hydrogens. Okay. Now count 1, 2, 3, 4, 5. Okay, 5 carbons. Here 3 plus 1, 4. 4 plus 2, 6. 6 plus 3, 9. 9 plus 3, 12. Yes. So this also 12 hydrogens. Now I'll write the third one. Okay. Third one also I'll write. Third one, how can I write the third one? Okay, so see the third one. I'll write 1, 2, 3, 4, 5. So 5 carbons are written, right? Now this carbon has only one bond, so it requires 3 hydrogens. This carbon has only one bond, it requires 3 hydrogens. This carbon has only one bond, so it requires 3 hydrogens. This carbon has only one bond, it requires 3 hydrogens, right? This carbon already 1, 2, 3, 4, it's balanced. Okay, so now check 1, 2, 3, 4, 5, 5 carbons. 3, 3, 6, 3, 9, 3, 12 hydrogens. Yes. Now if you see all these three, 1, 2, 3 structures having same formula C5H12. Once you check. Okay, so C5H12, right? Now compounds is same. Does they possess the same similar type of chemical properties and physical properties? No, they do not possess similar properties because they differ in their structure. This is linear with one branch, this is linear with two branches. So now they differ in the structure. So now they are having same formulas, but their properties are different, right? For example, now how can you give the name? So yes, linear 5, so this is called pentane. You know that. And generally we write N-pentane because that is natural pentane. Okay. Now second one, what we write? We can write this one. So see here, 1, 2, 3, 4. So in the straight chain, 4 carbons are there. 4 carbons is called butane, correct? Bute. And all single bonds are there, butane. Okay. Now give the numbering 1, 2, 3, 4. For second carbon, here one CH3. CH3 is called methyl. So you have to mention 2-methyl. So the name of this one is what? 2-methyl butane. Right? Now come here now. Here you see 1, 2, 3 in this chain. Otherwise you can count like this also. 1, 2, 3. So 3 is what? Propane. Correct? So 3 is propane. Okay. If you give the number first carbon, second carbon, third carbon. For second carbon here above 1 methyl is there. For down another methyl is there. So total how many methyls are there? 2 methyls. Where? For 2 only. So 2, 2. Then how many methyls? 2. So 2 is called a dimethyl. Now the name of this one is 2, 2 dimethyl propane. Right? Now they differ in structure, that we know. But one more important structure difference what you find? You find the most important this one is that here the root word is pent. Pent means what? 5 carbons. The longest chain consists of 5 carbons. Here the longest chain is bute. Bute means what? 4 carbons. Here chain consists of 4 carbons. Here propane. Prop means what? 3 carbons. So the chain consists of how many carbons? 3 carbons. So you have 5 carbons, you have 4 carbons, you have 3 carbons. So meaning is what? They are differing in the chain. This chain, longest chain consists of 5 carbons, longest chain consists of 4 carbons, longest chain consists of 3 carbons. So differing in the chain. So that's what this is chain isomerism. Which isomerism this is? Chain isomerism. So chain isomerism is a part of structural isomerism. So they differ in the structure. Okay? They differ in the structure. Right? They differ in the structure, but at the same time, they also differ in the chain, root word, longest chain. So that's what they are called chain isomers, and this phenomena is called chain isomerism. Clear, students? So in this way, the chain isomerism will be there, and we can continue. You practice some, okay, other one. Tomorrow in the next class, we also discuss the chain isomerism with the functional groups. Okay, because already you discussed the functional group. Okay, so you should it become like once revision for the functional group also. Okay, so in the next class, we are going to discuss about the isomerism. In that again, chain isomerism only with the functional group. If the functional group are included, okay, that also we check. Okay, so that's all. So with this, we stop the class. Okay, the next class we continue with this chapter. Okay, bye until take care.